right, so in this next lesson, we are going to look at a couple more ratios when it comes to dealing with right triangles. All right, so in this lesson, we're going to be finding angles again, but this time there are two more ratios. They're called the sine and cosine ratios. All right, so when it comes to trigonometry, there are actually, a total of three ratios for right triangles. The tangent ratio is the one that we've been working with in the first two lessons. Now what we're going to do is introduce the sine and cosine ratios. So the sine and cosine ratios, they will involve the hypotenuse. Right? So if you recall, the tangent ratio for the previous lesson was equal to opposite over adjacent. So this is when we're working with questions that did not involve the hypotenuse. What the sine and cosine ratios are is they actually, when the question involves the hypotenuse, we got to either use the sine and cosine ratio. All right. So so let's look into this first example. So we want to determine the measure of the indicated angle. All right. So we want to find this angle here, angle E. And our steps are still the same. All right. First step here is we're going to label the sides, right, of this right triangle. All right, so for the right angle, across from it is always the hypotenuse. So I'm just going to write HYP for short, hypotenuse. And since we're working with angle E here, 4 here is your opposite side. And the side next to it is the adjacent side. All right. So that's how you label sides. Remember, again, the hypotenuse is always a hypotenuse. It's always across from the right angle. The opposite adjacent depends on which angle you're working with. Right? So since we're working with angle E here, the opposite side is across from angle E, which is the length of 4. The adjacent side is the one next to it. Then our next step is to set up the equation. All right, so now when it comes to setting up the equation, we have to choose the correct ratio to use. All right. So that's the first thing we're going to do. We're going to choose the correct trigonometry. I'm just going to call it trig ratio. Now, to do that, there's an acronym that is fairly popular or famous. It's called SOHCAHTOA. So what this does is it allows you to choose the correct ratio. All right, now what SOH stands for is a way to remember that sine. You might read it sin. It's just the abbreviated form, but it's actually, you should read it as sine. Sine is equal to opposite hypotenuse. The CAH or the Ka is cosine equal to adjacent hypotenuse. And TOA, this is the ratio that we've already been working with, tangent, is going to equal opposite over adjacent. Okay, so SOHCAHTOA, this is just a way to remember the three ratios and what they mean. All right, so in this case, if I look at this diagram, what you'll notice is the adjacent side is blank. So for this question, I want to use the ratio that involves the opposite and hypotenuse. So again, opposite has a length of 7, hypotenuse has a length of 4. Notice that the adjacent side here is blank. Okay, so of these three ratios, the one that involves opposite and hypotenuse is the first one here, sine. Okay, so this is the one that I want to use to set up the equation. All right, so when I set this equation up, I'm going to write sine and angle E. So I'm going to just call it, I'm just going to write angle E. The sine of angle E equal to opposite, which is the length of 4. Opposite is 4 and hypotenuse is 7. So you know what? It looks a little funny. There's the angle sign there. And I'm just going to write sine of E. All right. Okay, so I want to find an angle E here. Subbed in 4 for the opposite side, 7 for the hypotenuse. Now, to find angle E, just like we did with the trig ratio or tangent ratio in the first lesson when we're trying to find the angles, I'm going to punch in sine inverse of 4 over 7. All right, so with the way that works in the calculator, I'm going to punch in 4 divided by 7. All right, so as a decimal, it's 0.571. All right, so again, this is 4 over 7, that number there. And to get to punch this part in, sine inverse, the trig second function. All right, I'm trying to find an angle. All right, so on your scientific calculator, you should have a second button or a shift button on the top, I believe top left. Just make sure you hit that first before you hit sine. All right, and what ends up coming up here is the actual measure of angle E. All right, so as it turns out, it's going to be 34.8 degrees. Okay, so angle E here equals 34.8 degrees. Okay. Yeah, so that's the measure of this angle here. All right, so let's try another one. We want to determine the measure of the indicated angle again. All right, so again, first step here, I'm just going to label the sides. So across from here is my, across from a right angle is always your hypotenuse. And this time the 2 here, or sorry, we're working with angle A here. So across from angle A is your opposite side. Next to it is your adjacent side. All right, so I've labeled the sides. Now I'm going to write up SOHCAHTOA. And this time I want the ratio that involves the adjacent, the hypotenuse, right? So notice the opposite side here is blank. I'm not looking for it or anything, so I'm not going to use that one. So of these 3, the one that has adjacent and hypotenuse is the middle one here, CAH, right? Adjacent hypotenuse. So if I'm going to set up the equation here, I'm going to write down cosine, and I'm trying to find angle A is going to equal adjacent, which is 2, over the hypotenuse, which is 5. Right, so cosine A equals 2 over 5. So therefore, A is going to equal cosine inverse 2 over 5. All right, so to plunge that into my calculator, 2 divided by 5 equals, and then hit trig, second function cos inverse here. And you can see that it's 66.4 degrees. All right. Cool. Yeah, so again, what you do is first step is you label the sides. Next, you pick the right ratio, set up the equation, and then it's always going to be the inverse of that ratio. Okay, cool. So we got one more question here. If you have an observer sitting on a dock watching a float plane that is 430 meters away, flying at an altitude of 300 meters, determine the angle of inclination of the plane measured from the observer to the nearest degree. All right, so this is just describing a situation. So what we want to do first here is actually draw what's happening here. All right, so we have a person sitting and he sees a plane. All right, it's my plane, float plane. So put floaties on there. I don't know. All right. So the distance from the observer to the plane is 430 meters. And it's flying at an altitude of 300 meters. Okay, so it is, the plane itself is 300 meters above the ground, water. So we can assume that this is 90 degrees. Okay. Now the angle of inclination is also sometimes it's called the angle of elevation. It is the angle between the horizontal, so the flat line, and looking up. So in other words, it's asking you to find this angle here. Okay, so this is the angle of inclination. All right. So now that I've set up the diagram. I'm going to label the sides. Again, across from the 90 degrees here. This is my hypotenuse. And this angle is the angle I'm looking for. So across from it is my opposite side. And actually, you know what? I'm not even going to bother label this as adjacent because it's blank and I'm not going to use it. All right, so I want from the acronym SOHCAHTOA, I want to use the ratio with opposite and hypotenuse, which is the first one here, sine. Okay, so if I set up the equation, it would be sine of, and actually, you know what? We'll go back to theta, and how to call this angle theta, is equal to opposite, which is 300, over hypotenuse, which is 430. Right. All right. So to find angle theta, I'm going to punch in sine inverse of 300 over 430. Right. So that should give us the answer. All right. So 300 divided by 430 equals. All right. So this is 300 over 430. And we want to hit sine inverse of that. Second function sine. All right, so as it turns out, the angle itself is going to be 44.2 degrees. All right, so that's the angle of inclination, or sometimes called angle of elevation. All right, cool. So that is the sine and cosine ratios.